Eric Burgess here, and we've been asked to find the exact value of sine of negative 13 pi over 12. Now, looking at this, we can recall a couple things. First, let's look at if this is even a reasonable value. Can we do this with a unit circle? So the easy way to tell that is if we really quick just draw a unit circle and look at the first quadrant, it sort of tells us all the different fundamental units we can move in. We can move in pi over 6, we can move in pi over 4s, or we can move in pi's over 3s. So 12's not on here. 12 would be like right here, right? It'd be less than pi over 6, half of that. And because of that, that makes it difficult to work with. So what we're going to need to do is we're going to need to take this 13 pi over 12 and we're going to need to make it so that it's some combination of these units instead. So 12, if we look at this, well, we say, okay, well, how can we break this up? Well, 12 can be broken up as a combination of, we need to break it up into either 4s, 6s, or 3s, or some mix of them. So let's see if we can't do that. So I'm going to first break it up into 6s. What the heck? So if we want to do that, what we need to do is we need to take 13 pi over 12. That's what we're interested in. The negative sign we can kind of ignore because sine is an odd function. And remember that odd functions have this property. If you put in the negative x, you get the negative of just whatever it is. So we're going to use that with sine. And we could say that, if we find sine of negative 13 pi over 12, that's going to be the same thing as finding the negative of sine of 13 pi over 12. So whatever we find at the end, we just simply make it negative and we will get the answer. So we can just put a negative on the outside of this. So now we turn our attention to ways we could break this up. So with the 12, let's see if we can't break it up into some combination of 6s and 4s. Possibly 3s could get involved. I don't know. Let's do some experiments. So if we have, let's just say pi over 6 plus pi over 4, let's just see what number do we get out when we do that. So to get them both to have 12s on the bottom, we'll multiply by 2 on the first one. So we'll have 2 pi over 12. And we'll multiply by 3 on the second one. So that'll be 12 on the bottom and then a 3 pi on top. So if we put these together, and I highly recommend writing it going down like this so you can see the different steps. It'll make it easier to figure out what they can add to give you the original. If we do this, we'll get 5 pi over 12. So that's not quite there. We need 13 pi. And so to get to 13, we need an additional, what do we need? We need an additional 8 pi. So we need an additional 8 pi over 12. So if we add an 8 pi over 12, we will get what we want here. Now we want to add this 8 pi over 12 in a way that will go backwards, that we can get back to the pi over 6, pi over 4 deal. And if we do this, we will get a 13 on the top and a 12 on the bottom. So from here, let's say, okay, well, if we add the 8 to the 3, we're going to get 8, 9, 10, 11 pi over 12, which won't simplify back down. So that's a no-go. If we add the 8 pi to the 2 pi, we're going to get 10 pi over 12. And this does simplify down. This can simplify down to if we divide by 2, we'll get a 6. And on the bottom, we will get a, what is that? That's a 5. We're just dividing by 2. 5 pi over 6, totally chill because we have a 6 on the bottom. So that means what we want to do, in fact, I'll leave this here, is we're going to rewrite this whole thing as 5 pi over 6 plus 3 pi, or just pi over 4, not 3 pi. Because remember, this is the same thing as pi over 4. That's why I wrote it in this way, so we can see it going backwards. So this is equal to 13 pi over 12 as well. So these could be a bit tricky to work with, but just pick some basic units, add them together, ask what you're missing, add it on there and see if you can combine it in some way that will reduce down to a 6, a 4, or a 3, or a 2. 2 will work as well, right? Because we have pi over 2 as well. That's the last fundamental unit we can move. So this is the winning combo. So we're going to take this and we're going to use the sum of angles identity, because what we're saying is negative sine of 5 pi over 6, 5 pi over 6 plus pi over 4 is now our equivalent statement. We're saying that it's equal to our previous statement of sine of negative 13 pi over 12, using a couple identities and some clever movement. So now what we're going to do is we're going to use a sum of angles identity. So with sine, the sign stays the same. S for stays the same. So we're going to have a plus in the middle. And the way I remember it is my professor used a silly acronym called Some Cats Can't Sing. And so if it starts with a sine, it's some cats can sing. And then if it starts with a C, like a cosine, it's cats can sometimes sing. And what do I mean by all this cat stuff? Well, some cats can sing is some cats can sing. So we have sine, cosine, cosine, sine. That's how I remember it. I know it sounds silly, but I kid you not, this little memory trick has saved me on quite a few tests. So, and I still remember it just randomly. So it's pretty good, I think. And then we just fill in our angles. So we're going to have 5 pi over 6 here, pi over 4 here, 5 pi over 6 here, pi over 4 here. So to find the sine of 5 pi over 6, we're going to come to our unit circle. And if we think about it, we are moving in basically slices of pi, right? Here's 1 pi over 6. Then if we go another slice, we're going to move in 2 pi over 6. So we're going to have 2 pi over 6. And if you look at that, that reduces to pi over 3, which is why that's pi over 3 here. Then we move another slice, and we're going to be at 3 pi over 6, or pi halves. This is the same thing as 3 pi over 6. So if we go again, we're going to be at 4 pi over 6. Then we move another slice. There's a middle slice here. That's where the pi over 4 would, the slice of pi over 4 would go there. And then we go over 5 pi over 6. So we see that this angle here shares some properties with this side over here. And on this side, we've gone more in the x direction than we have in the y direction, right? So the y direction is going to be smaller. And so the rad 3 over 2 is bigger than 1/2. So that's why rad 3 over 2 goes first. Some people also remember it as they count like 3, 3, 2, 1 for the different angles. And then they put 2 under everything and put a rad over anything that's not a 1. That can work too. I just, it's a little, I mean, I'm the guy who's a fan of the cat method though. But I just think this is a little bit easier of a way to remember it. It just tends to make a little more sense. I don't have a more sensical way to remember this off the top of my head. So, I take what I can, but whatever helps you remember it, just go ahead and use that. And so on this side, we're going to be going this way to 5 pi over 6. And so the cosine will be negative and the sine will be positive. So that means that we're going to have a positive 1/2 here times, and now cosine of pi over 4 is a freebie. It's right here, and this one is easy to remember. At least I've never had a problem remembering it. That's rad 2 over 2. So we're going to get rad 2 over 2. And we're going to add cosine of 5 pi over 6. Now cosine of this over here, the cosine is the x direction, and this is going to be negative on this side. So instead of positive rad 3 over 2, we're going to have negative rad 3 over 2. So we're going to have negative rad 3 over 2 times sine of pi over 4, which is again just rad 2 over 2, a freebie. And if we go ahead and calculate this, we're going to get negative, and then on the side we're going to have rad 2 over 4 plus, actually we'll have a minus, and then it's going to be rad 6 over 4. And so this is going to be equal to, and the 4's can be combined, so we're going to have negative, and we're going to have rad 2 minus rad 6 under 4. We're going to have a negative rad 2 plus rad 6 under 4. And this is our final exact answer. Now we can check it, of course. If your teacher is fine with you using a calculator, we can really quick verify it using a calculator. So if I pull one of those out, we'll turn it on and we'll go, okay, let's test this first one. We have sine, I swear I know where sine is, of negative 13 pi divided by 12. And we get out this value, 0.258819 stuff and stuff. So now if we go ahead and use what we've done using the fact that it's an odd function and using the summation identity, we got this expression, and this should be giving us the same number. So if we type a fraction here, I'm going to type a fraction using their special fraction method. So I'm going to do the square root of 2 minus the square root of 6, or I mean plus. This should be a plus sign. Change that to a plus, over 4. And we get the exact same expression. So they are indeed equivalent statements, and we are able to find this exact expression using just a couple simple trig identities. And this could be pretty helpful, first of all, because this has, infinite precision. We used just mathematical identities, so we don't have to worry about some decimal places of accuracy to work with. And sometimes having forms like this can be easier to manipulate mathematically, and that extra precision can just be super important sometimes. If you have any questions about this, let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.